Hello, quality icons. Welcome to Quality Icons. Today we will learn everything about the concrete cube test, including sampling, casting, curing, compression testing, interpretation of results, application of IS codes, common site mistakes, acceptance criteria, and corrective actions. Every quality assurance and quality control engineer and site engineer should know. Let's begin. So myself, I am Jupalli Murali Krishna, QAQC AGM, with over of 20 years of experience in high-rise buildings and infrastructure projects, like power projects, water projects, different multiple projects. So coming to the point, why cube testing is important? The first, concrete cube testing is one of the most important quality control activities in construction. It verifies whether the supplied concrete has achieved the required compressive strength. Remember it. It verifies whether the supplied concrete has achieved the required compressive strength. Proper cube testing helps us verify concrete quality, monitor mix consistency, ensure structural safety and integrity also, and detect quality issues at an early stage, and avoid expensive repair or structural failures. Remember, strong structures begin with reliable concrete testing. See this image. The first one is RMC truck. This is very minimal points. Concrete pour, tube casting, curing tank, compression testing machine, building under construction, building or anything else, any project. Okay. What is the applicable of IS codes? Before performing cube testing, every engineer should know the relevant Indian standards. That is May IS 516 Part 1 2021. This is for the compressive strength test. You know that about the IS 456 2000, that is for the that is provides a general requirements for plain and reinforced concrete. IS 4926 covers ready mix concrete and production and quality. IS 1199, it is for the specific fresh concrete sampling procedures. All of you know that IS 10262 2019 covers concrete mix design. Always follow the latest revision of the applicable Indian standard codes along with your project specifications. So coming to the point, what equipments required for the concrete cube test? The first, cube mold. The essential requirement includes a standard 150 by 150 by 150 millimeter tube mold, ISA with ISA mark, clamping rod, scoop, rover, vibrating table, where applicable cube mold oil, that is releasing agent or etc. Permanent marker, cube identification tags, curing tank, and a calibrated compression testing mission of CTM. So coming to the next step, how sampling the procedure. What is the methods? What is the requirements? Concrete sampling begins when the transit mixer arrives at the site. Never collect concrete from the first or last discharge. As per Indian standard practice, Collect the sample after approximately 15 to 20% of the concrete has been discharged. This ensures that the sample truly represents the entire batch. Proper sampling is the first step towards obtaining accurate strength results. Please remember it. Proper sampling is the first step toward obtaining accurate strength results. Sampling key points. First, transmitter transit mixer arrives. Second, start discharge. 3. Take sample. 4. Sample quantity. Collect sufficient quantity as per IS 1111 part 5. Step number 5. Transport carefully. Use clean damp containers. Avoid segregation. 6. Proceed to cube casting. Cast cubes without delay as per standard procedure. Proper sampling ensures accurate test results and true representation of concrete quality. Next step is cube casting procedure. Already we completed the know how sampling procedure. The next step is cube casting procedure. This is very important, guys. Cube casting must be carried out carefully. First, clean the cube mold thoroughly. Next, apply a thin layer of mold oil or releasing agent, etc., etc. That is approved by the project specification or approved by the QAQC engineer, approved by the project head. Fill the mold in three equal layers. Fill the mold in three equal layers. Compact each layer using a 35 tamping strokes or by using a vibrating table where applicable. Strike up the top surface smoothly and level it with a mold. Finally, identify each cube clearly with the concrete grade, date, location, cube number and testing age. Proper casting produces reliable test specimens. Friends, this is very important casting procedure. The number of layers, number of blows, stamping blows, they're very important. The step one, clean cube mold. Step two, apply mold oil. Step three, fill mold in three equal layers. Fill first layer, one third of mold. Second, fill second layer, one third of mold. Third, fill third layer, one third of the mold. Each 35 tamping strokes. Each layer, 35 stamping strokes is very important. Or compact using a vibrating table where applicable. It is required. You can go with the compacting table. Step 4. Proper compaction. Step 5. Strike up the strike off surface. Strike off level with the top of the mold. Smooth finish, proper identification before curing. The mark cube is where the traceability of the cube is very important, guys, because in QAQC department, the traceability is the one of the most critical function. Concrete grade, finding date of casting, location, element, anything else. Cube number, age, how many days? 7 days, 14 days, 28 days. Because some people have do the 3 days, 7 days, 14 days, 28 days because of the that project requirement based on the project type of high-rise building or anything else, etc. Remember, correct cube casting today ensures reliable strength results tomorrow. The next step is very important, curing. Please remember this point. Concrete is equal to born baby. Okay. Proper curing ensures strength, durability, and reliability. After 24 plus or minus half an hour, carefully remove the cubes from the mold. Immediately transfer them into clean curing water. Maintained at 27 plus or minus 2 degrees Celsius. The water temperature is maintained at 27 plus or minus 2 degrees Celsius only. Avoid late curing, dry curing, improper water level, or dirty curing tanks. Proper curing is essential for achieving the required concrete strength. What is the mistakes? Late curing means delaying curing reduces early strength and overall performance also. Dry curing. Dry curing leads to loss of moisture and reduced strength. Improper water level. Water level should be at least 25 above the top of the cubes. This is very important. Dirty curing tank. Dirty water or tank causes contamination and affects strength. So every 15 days you can keep and clean the tank. It will maintain a register also. Proper curing is essential for achieving desired strength, durability, and long-term performance. After curing step is completed, coming to the compression test. Compression test means CTM. Just like this is the laboratory test called as CTM. CTM means compression testing machine. Compression testing machine performs the concrete compressive strength. The compressive strength testing machine measures the compressive strength of the cube, ensures that the cube is placed exactly at the center of the machine. Apply the load uniformly without any shock. Maintain the loading rate as specified in IS 516. Record the maximum load at failure. Calculate compressive strength by dividing the maximum load by the loaded area. Please calculate compressive strength by dividing the maximum load by the loaded area. Accurate testing provides reliable strength values. See the cube. Cube specimen always shows the identification of the grade, date of casting, which tower or which element, which cube ID is very important. See the example for the compressive strength FCK is equal to P by A. P is equal to maximum load, Newton or kilonewton. A is equal to loaded area, square mm. Okay, that cube area is equal to 22,500 mm square mm. See the example. P is equal to, for example, 475 kilonewtons. That is equal to 4,75,000 newtons. That area, cube area is equal to 22,500 square mm. FCK is equal to 47,000, 4,75,000 by 22,500 is equal to 21.11 Newton per mm square. That is easy. That is equal to 21.11 MPa, megapascals. Observe failure pattern. This is also very important. That means pattern. Cone type failure is acceptable. Note, any unusual cracks or irregular failures. Acceptable is cone type failures. Not acceptable shear failure, columnar failure. Was not acceptable. During testing, the loading rate also is very important, guys. Apply load at the rate specified in IS 516. The loading rate is equal to 140 plus or minus 70 kg per centimeter square per minute. After completion of the testing, you have the acceptance criteria. Coming to the acceptance criteria. 7-day strength generally reaches around 65 to 70% of the character strength, depending on cement type, supplementary cementitious materials, and the approved mixed design. 28-day strength must satisfy the project specifications and applicable IS code requirements. Remember, Acceptance should be based on your project statistical criteria and not on a single cube result alone. Statistical acceptance the right way. Evaluation should be based on the required statistical acceptance criteria rather than a single cube whenever applicable. Typical acceptance basis as per IS 446 or project specification. Minimum 3 cubes are as specified from the same sand. Calculate the average strength. The average strength shall be greater than or characteristic strength. The characteristic strength means FCK. No individual test results shall be less than FCK minus 4 ton per mm square. Follow the specific criteria mentioned in the project specifications and project applicable Indian standard codes. Consistent testing, correct curing, and proper evaluation ensures structural safety and durability. It's also integrity. Test right, build right, be responsible. Coming to the common site problems. Common site problems. Low cube strength may occur due to excess water, poor batching, incorrect mix proportions, inadequate curing, segregation, poor vibration, or expired cement. This is the material part. Expired cement is the material part. Friends, we will discuss later on the material part also. These issues may lead to structural weakness, cracking, rework, and project delays. High variation between cube results may be caused by improper sampling, different curing conditions, CTM calibrations. Equipment calibration is the very important. CTM calibration differences are incorrect testing procedures. Whenever abnormal results occur, conduct a joint investigation and a compare plant cubes and site cubes and third-party laboratory results. This is very important. Joint inspections are compared to third-party inspection, third-party laboratory results. Whenever, as per your convenience. See guys, here we are clearly defining on the images and problems, QC action, what is the variation, what joint investigation causes. Please see it. Low strength causes excess water, poor batching, wrong mix, poor curing, segregation, improper vibration. Vibration also is very important, guys. How to put the vibrator needle is so very important. Expired cement, this is the material part. Problems. What is the problems? Structural weakness, cracks, rework, delays. Delay is the most important. All of the impacts goes to the project delays. The delays will be depending on the cost will be increasing on the project budgetary. What is QC action? Batch report verification, slump verification, cube records, curing records, CTM calibration, cross-checking, and cement test certificates. So that means manufacturing test certificates produced by the manufacturer and cross-check at our internal laboratory or third-party laboratory and verify the cement testing parameters. What is the high variation? Causes improper sampling. The improper sampling means the technicians or supervisors, the QC supervisors are not full trained, will be impacting on the improper sampling. Different curing conditions, the temperature variations, the curing tank is temperatures control, temperature control is very important. Different CTM calibrations, without calibrations, via deviation calibrations, that is also important on the strength part. Variations, high variations. Improper loading. During testing, the cube specimen is put on the center place of the CTM machine. Action. If suppose any problem is coming, the root cause finding is very important. Investigation. Investigate together. Compare. Compare with plant cubes, third-party cubes, site cubes. Identify the root cause. Take corrective action. Ensure consistent quality. Prevent problems before they affect the structure. This is the frequent site mistakes during cube casting, cubes taking up samples. Okay, please see the image. Avoid these mistakes, ensure accurate results and quality concrete. Nutty molds without oil, without applying of oil, wrong sample collection, sampling from wrong location leads to unrepresentative results. Excess vibration, over vibration causes segregation and reduces strength. Poor compaction, insufficient compaction causes voids and lower strength. Delayed casting. Delayed casting leads to partial setting and poor strength. Delayed casting and the means concrete, all mixed designs are put together within completion of 3 hours. That is the batch start to completion of the end pour. Improper curing, wrong identification, incorrect or missing details lead to mix up and wrong results. This is a very important point in the laboratory maintenance. Testing before required age. Testing before required age gives misleading and low strength results. 7 days, 14 days, 28 days, etc. Uncalibrated CTM gives inaccurate strength results. Incorrect loading positions. Earlier we discussed with the specimens, cube specimens placing on the CTM. Eccentric loading causes uneven stress distribution and error erroneous results. Broken cube corners. Handling and transport damage leads to unreliable results. Broken cube corners is very important. Cube sample placement is very carefully. Proper care is must be needed. Accurate testing starts with avoiding mistakes. Follow procedures, ensure quality, build stronger structures. All this is the very quality icons. Please, the cube testing sampling procedures, all including is one part of the QAQC checklist. Every quality assurance engineer should verify what is the checkpoint, what is the checkpoints, what to verify. The first is the concrete grade. Verify the grade as per project specification. That is means M30, M40, M50. M means mix. 30 means the character strength of the concrete grade. So next, transit mixer number, record mixer number for traceability. Compare with the batch sheet. Delivery time. What is the note the arrival time of concrete at site? Check with the batch end time of the with the batch slip. Slump value. Check and record slump value as per project requirement. For suppose you are doing with the M40 with the pumpable concrete, that is different for the different slump required for the different slump. So you can go with the SDC or SCC, that was different with the different workability, that workability flow. Sampling method. Ensure sampling is done as per IS code and standard procedures. Cube identification. Verify proper identification on each cube. Cube mold condition. Check mold cleanliness, tightness, and condition. Diagonals of the cube molds, tightness, ISI marks. Compaction method. Ensure proper compaction by tamping or vibrating table. Curing tank temperature. Verify water temperature between 27 plus or minus 2 degrees centigrade. Cube age. Ensure cubes are tested at the required ages. 7 days, 14 days, 28 days. CTM calibration certificate. Check and verify valid calibration certificate of CTM. Cube test register. For the record purpose, verify entries in cube test register are correct and to date. Ensure test report is complete, accurate and signed. This is called verify, record, confirm, ensure quality. Accurate checks lead to reliable results. This is also be practical case studies. Case study one. Let's look some practical examples. Case one. Low cube strength due to improper curing. What is the solution? Improve curing process. For example, the vertical members, I like think columns or retaining walls, shear walls, anything else that will need to always put on wet condition only. Any rafts or slabs, horizontal members, horizontal elements will be should kept on the water spawning. Case 2. Q failure. Q failure caused by unauthorized water addition, means excess water added at site. What is the solution? Never permit never permit water addition at site without approval. Please remember it. Never permit water addition at site. Case 3. Strength variations. The strength variation caused by improper sampling. Earlier we already discussed about the variation, strength variations. Improper sampling means train site engineers and QA/QC staff, supervisors, lab technicians. Proper training is must needed. Each activity training is the one of the essential for the quality assurance and quality control. Case coming to case 4. Different results. In-house versus third party. That means 28 days cube. So for example, the 28 days cube strength the M30 is given here. Sample ID is C1, C2, C3. In-house results 38.5, third party results 32.1. The difference is 6.4. See the variations. In-house 38.5, the third party results 32.1. Why the difference is 6.4 MPa, 7.47 MPa? Reason? CTM calibration errors, functioning, that CTM calibration difference. Conduct a joint CTM calibration. The solution is conduct a joint CTM calibration and comparative testing. These all case studies, learning from these cases helps prevent future failures. Friends, this is the closing message. Quality today, safety tomorrow. Quality today, safety tomorrow. The safety means structural integrity or anything else. Safety also be one of the most important point in construction sector. Concrete tube test is much more than a laboratory procedure. It's one of the most important quality control tools in construction. Everyone knows, I know cube sampling, I know cube testing, but it's very important, guys. Is one of the most important quality control tools in construction. Cube testing is cube sampling or cube testing. Proper sampling, accurate casting, correct curing, and calibrated testing ensure reliable strength results that truly represent the quality of the concrete. Every QA/QC engineer has the responsibility to maintain these standards because today's quality checks determine tomorrow's structural safety integrity. Always follow the approved mix design, project specifications, and applicable of IS codes before accepting any concrete. This is for the QC engineer decision tree. Cube test, making the right decision on site. Complete cube testing 7 days and 28 days. Cube pause. Continue concreting and monitor results. This is for the what do the results show. The second is 7 days strength low. For example, it comes under low. If 7 days strength is low, review the slump values, batching records, curing practices, and sampling procedures. This is very important, guys. If you have found any problem, any variation or deviation, that values, the slump values, batching records, curing practices, and sampling procedures, thoroughly verify it. If 28 days strength fails acceptance criteria, stop acceptance of the affected concrete. Investigate the root cause. Verify CTM calibration and consider further assessment as per the project quality procedure. In fourth point, high variation strength. If high variation exists, audit the RMC plant, laboratory practices, curing conditions, and sampling methods to identify the actual cause. Always make decisions based on the data, not assumptions. Clear? Always make decisions based on the data, not assumptions. Decide, act, verify, improve. Data driven decisions, quality focused construction.